All right, so this is an example of the project, just kind of going through each characteristic one by one. So this is just an example of a function. So negative x squared plus 7x minus 6. So that is in standard form. Remember, standard form will not have all the parentheses in it. So you won't have something like negative parentheses with an x minus 2 and another parentheses with an x plus 4 or something like that. All right, so for this one, to classify this one by degree and the number of terms, it's considered a quadratic function because of that x squared, and then it's considered a trinomial because there's 3 terms. So here you would put quadratic trinomial. If it had 2 terms, it'd be a quadratic binomial. All right, now we want to look at symmetry. Now remember, with symmetry, it all depends on whether or not you can fold it in half like a book with the y-axis being in the middle, or if you can rotate it 180 degrees around the origin and it still match up perfectly. All right, so this particular function, you can fold it in half like a book. The problem is that's not the y-axis. So this particular function does not have symmetry. All right, now you also have to determine if it's an odd or even function. Now, odd functions go in opposite directions. So opposite direction would be something like this. Well, this particular function is not opposite directions. It's going in the same direction, right? So that would be an example of an even function. All right, so you can be an even function and not have even symmetry. All right, so then my roots or my zeros are where the graph crosses the x-axis. That crosses at 1, 0 and 6, 0. So I guess we'll put just 1 and 6. 1 and 6. All right, if it had asked for the x-intercepts, then I would have put the full ordered pair 1, 0, 6, 0. Okay, but roots and zeros are just the actual solutions. All right, so then the y-intercept. Now this graph is deceiving. When you look at it, you're like, well, it doesn't cross the y-axis. All right, however, it eventually will. So if I could see the rest of that graph, eventually it would cross. So you don't guess. That's going to happen when x is 0, right? So when x is 0, what is the y value? So if I looked at my original function, if I substituted in a 0, these two terms would cancel out because 0 squared is 0. 7 times 0 is 0. And all I'm left with is a negative 6. So whatever your constant is at the end, that will be your y-intercept as long as it's in standard form. All right, so my y-intercept then is 0, negative 6. All right, so then it asks for a minimum, and it can be an absolute or a relative. But because this graph keeps going down forever, there is not a minimum. All right, you could say negative infinity, I guess, but that's not something that would ever reach. Okay, so we don't have a minimum. All right, so then we do have a maximum. It's right here. This is the top of our ripple. So our maximum is 3.5, 6.25. All right, and because that is the highest that graph can go, then that maximum would be considered an absolute maximum. So then you would circle absolute maximum. Now, the domain for all of these types of functions, polynomial functions, is negative infinity to positive infinity. And that's because it goes forever left and forever right. It never stops. It's a continuous graph, all right? You have to put the negative before the positive because it has to go small to big, all right? Now, for the range, you think, well, how low can my graph go? Well, the graph goes down forever, right? So the graph goes to negative infinity. That's the lowest it can go. But how high can my graph go is up here. Now, that is not 3.5. Think about where that is on the number line, right? And that would line up with definitely over 5. And it's the y value of that maximum. So it would go up to 6.25. But since that point is inclusive, it gets a bracket, all right, instead of a parentheses. So we use parentheses when it's approaching something or when it's non-inclusive, but we use a bracket if it is inclusive, all right? So now we're going to talk about the interval of increase and decrease. So what you have to remember is your graph goes from negative infinity to positive infinity, right? So I'm looking down here at the bottom, okay? It always goes from negative to positive infinity, always. All right, but what we have to do is figure out, well, where does this graph turn? So think about what's happening with your function, all right? It's like you're going up, and then you get right here, and then you start going down, right? So that's my interval of increase and decrease. All right, so where does that turn happen? Well, it happens right here. It lines up right here, and that is at 3.5. So you always use the x value, not the y value. All right, so from negative infinity to 3.5, my graph is going up. So negative infinity, I'll fix that in a minute, to 3.5, my graph is going up. All right. And then from 3.5 to infinity, my graph is going down. All right. So that's my interval of increase and decrease. So my interval of increase comes from this right here. It's going up from negative infinity to 3.5. And then my decrease, this side of my graph is going down. So 3.5 to positive infinity. Now, both of these get parentheses and not brackets because this little point right here is kind of like a pivot point. It's not increasing, it's not decreasing. It's that one little microsecond in time when you're changing directions. All right, so the last thing is the end behavior. The end behavior, as x approaches positive infinity, that's talking about the right side of your graph. What is the f of x doing? Well, that's the y. All right, so y's go up and down. So as x goes to positive infinity, that's the right side. What is the y value doing? Is it going up or down? Well, what is the right side of my graph doing? It's on the downside, right? So that would be negative infinity. All right. And then this part says as x approaches negative infinity, that's talking about the left side of my graph, is it going up or down? Well, this side is also going down because it's on the down side. All right, so that is also negative infinity. So if this graph was going up, like if it was a graph like this, then that would be positive infinity and positive infinity. If my graph looks something like this, then the left side of my graph would be going down, the right side of my graph would be going up. So hopefully this video helps you a little bit with your project.